spoiled my intro. Yeah, where I was about to explain that I met you at a tech conference at Disney World and you set things on fire, but now everyone knows you set things on fire, so I'm not useful here. Make James welcome.
Thank you. Can you hear me okay? Is the mic on? Good enough? Can you hear? No. Oh yeah? Hey, better? Can you turn the gain down a little bit in the room? Because it's a little loud for me. All right, so I'm going to go very, very quickly, and I apologize about that. The bad news is I'm going to go very, very quickly. The good news is I'm also giving a main talk, which is going to be about the same subject, except I was hoping to focus this one a little bit more to developers. Can you turn this down? It's really loud. Yep. Oh, you have to turn it down here. Thank you. I'm going to introduce you some stuff. I just have this video from Montreal. I'm from Canada. I was going to make some Australia jokes, but they're really bad. So I decided just to show you this VHS sort of recording of some snow we had in Montreal. Oh gosh, that video is really kind of bad. It was a very early snow and people weren't prepared for the sort of slipperiness, and you can see what sort of unfolded. Yeah. That's our public transportation. They're never really on time, especially when they slide down the hill like this. I'm sure they use this as an excuse now every time they're late. I know this is eating into my talk material, but I just can't not come all the way from Canada and not show you this. So I'm kind of a snow lover when it's cold. Boom! Don't touch any buttons, it's working. Just leave it. Oh, yeah. Oh, the mic. The police are here to save the day.
I lived in Dunedin, I'm used to this.
Yeah. And, but don't worry, it gets a little bit better because we have city workers who can come and fix these problems and put down salt. And as you expect, boom. All right, so I really have to go fast, I apologize. So I'm a hacker, I work on config management things. I write a technical blog called the Technical Blog of James. Who's seen it? Just raise your hand. If you haven't seen it, just raise your hand so I seem really popular. Thank you. Take a photo of that. I'm actually a physiologist by training, and I don't know how I got into computing. I'm really big into DevOps type things. Just a little background. Oh, can you turn on the computer audio? If not, no big deal. Long story short, I used to do a lot of Puppet automation. I was told I can make it a little bit more difficult and assume a lot of knowledge because I know you're a bright crew. And people are like, I was unhappy with some of the things in Puppet, and I thought there was a way to do things, but people are like, well, don't reinvent the wheel. But I kind of do want to reinvent the wheel because there's some very specific things that were missing in the traditional tools. And so I really sat down and said, is there an existing tool out there that is good enough for what I want to do in terms of autonomous automation and so on? And this is the gentleman who's going to answer that question. What do you think? You happy with your automation tools? Yeah. So that's the nope guy. And so everything's all nope. So long story short, I actually sat down and started writing a tool. I think I initially pushed some code out publicly around 2 years ago, and it takes quite a lot of work, so it's taken a while, but we're in pretty good shape now. We even have a nice logo and some stickers which you can come up and get at the end. The tool has two main parts. It has an engine, which actually does the work on the system, and it has a language which actually describes and models what you actually want to have it do. And it does some cool things. It can run in parallel, so it can run the graph of resources, which you might be familiar with other tools such as Puppet in parallel. It reacts to events, and it works as a distributed topology. So can everyone see that, or should I make it a little bit bigger? Is that good? Everyone? Yes? Who cannot see? Excellent. So what I'm going to do is I have, hello, I think I have an Australia. I have a nice little demo here. I'm actually going to just show you what it says in here. Made a little hello Australia demo. You have basically just a single file resource that's going to create a file with some contents that says hello. And if we just go and run that over here on the left, on the right, we're actually just going to see, did that get created? And you can see there's now actually one file. and it shows what you expect. But the really cool thing about this tool is it's a real-time reactive tool. So if the state on the machine changes because I'm a bad user and I delete it, you can see that instantly the engine wakes up, notices this, and fixes the state back to what you want. So you can remove it, and quickly, before I can even type the second command, the file comes right back. Someone said, whoa. Yeah, wait, hang on. This is just the beginner demo. So I can actually even remove the file and cat the file, and even before the second part of that runs, it'll come back right away in real time. And for those who are familiar with watch, watch is a little command that lets you run something over and over again. And if I run this whole command over really fast, you can see I've got all this debug output showing you that it's fixing it in real time. You like that? So now here's the thing. This is the point. Every single resource has a way of doing this. Files, packages, virtual machines, AWS VMs or whatever they're called, all of these different things. And I'm not going to expand about this too much because I want to show you some other cool stuff. But hopefully it'll trigger you enough to come back and look at some of the other material and help us build a great automation tool. So these are basically the graphs, the blue boxes being resources. As I said, we run them in parallel. I'm going to skip a bunch of things just for time. We do work as a distributed system, which is a whole interesting part. But again, this is a really short talk, and I'm already a little running late. So the interesting thing I want to talk to you a little bit more about is the language. So we actually built a language, and you might wonder, why do we need to build yet another language? Now, it's not a general purpose language. It's not something like Rust or Golang that's going to really be a full feature thing. It's a very specific DSL that works for this particular problem, and it has a very interesting reactive property. So I'll actually just show you a demo of this first. I have a nice little demo here, and I'm going to actually just show you what the code looks like first. I'll just pop this so it's a little bit bigger. So what this does is you have a variable here at the top. We don't have syntax highlighting yet. That's the problem with inventing a new language, where you have this date time function, and it actually is reactive and knows what the current date of time is every second. And we're just going to print that out to a file. So if we run that example, and I run this same little watch over here, date time. Oops, if I can type. So this is that file that actually is having its state being updated by the engine every second, because the code runs actually reactively in real time, and it detects that the date is changing every second, because naturally it does. And every second in that case, when there's a new graph that it needs to build, it pushes that out to the system and changes the file. Now this is a little bit arbitrary, but you might want to make decisions based on different sort of properties in your real system, in your live infrastructure. And I have an example to show you of that. It's a little bit, I'm just going to kill this so it goes fast. So I have a slightly different example. It's going to do a few different things. It's going to print out the date, just to show you that that's a property that you can look at. It's going to print out the load average, because the load average actually is, again, another real-time property that changes on Linux machines about every 5 seconds. And there's actually, just to show you how actually dynamic and creative you can get, I have this VU example at the bottom. And if we're very quiet, just listen for a second. But if you start talking, it actually notices, it's actually measuring the volume from my crappy laptop microphone in real time and translating that to a percentage from 0 to 1, to a fixed point approximation of that, and then putting out a little VU meter bar to show you how loud it is. So if you wanted, for example, in your infrastructure, wait, that's my like, big hey. But before you do the clapping to sort of make it peak, the point is you could build potentially a system where you're a sysadmin, and if you have the volume in the room going up for, pretty loud above a threshold, maybe that means you guys are screaming and fighting in the sysadmin room, so you should set everything to read only for like half an hour. Right? So, you like that? So if you want, for applause, we're going to be quiet, and we're going to be really loud and see if it really works, okay? So. All right. Cool. So it's a bit silly, it's a bit abstract, but the point is not that you should be doing this necessarily. The point is that you can actually use your imagination to build all sorts of real-time reactive systems. Systems aren't static. It's not a puppet run that just everything is in the correct state. You want to deal with failures, react to those failures, and model your system so that it can be autonomous. You sick of that, or you want to see some more demos? More demos. Come on, you want more demos? Yes. All right, you're very shy, that's cool. So we're just going to kill this. I'm just going to kill it really quickly. Pardon me? ask me at the end, and I will grab it, because we don't have the mic and everything. So just a few properties of the language, just before I show you another demo. The language is intended to be very, very safe. So we don't want to make it so that if you make a small off by one error that you blow away your data center. That would be really bad, because the tool works very, very quickly. It's very fast. It has some properties that are quite interesting. It's very powerful. It's reactive, as I showed you, and there's some other things we won't talk about today. And we're hoping that the language will be really, really easy to reason about. So by looking at the code, you can know for sure what it's going to do and not be like surprised by some bug. Because ultimately, even if we test as much as possible, there's a chance you could still make a bug. And some things are just very difficult to avoid. So I showed you this demo. Anyone know what this is? Just for fun? Scream it out. It's a thermostat. This is the one from my parents' house in Canada. It's kind of a blurry photo because my parents are not good at photograph technology. But thermostats have a very interesting property. Does anyone know what that property is?
It tells you how warm it is.
Yes, I knew someone was going to answer that. That's my joke. Besides telling your house how warm it is, it actually has an interesting property called hysteresis. And what that does is it basically lets you keep track of the state so that the thermostat doesn't flick on and off your heater, right? So you actually have some state, and you can actually model this in Mgmt. Since every variable has a time sequence of values, the previous value and so on, we can actually do things that when the load is at a certain value, do a certain action, but then when it drops down below some other threshold, wait and then actually perform the next action. So just a quick example of this, I have this hysteresis example. I'm just going to run this on the left. And I have here a little shell script. It's running watch every twice a second, and it's catting the output of this file where I'm putting some debug stuff, and it's doing a verse list. So we're actually going to run this, and you can see, since we have a virtual machine resource, these things can be controlled dynamically as well. In this case, we have two that are running, and I implemented a little hysteresis that when we get over 1.5, the load on the system, it's actually going to shut one of those machines down. Right? So this is sort of like an auto-scaling example that's all done in a single tool. So let's just increase the load artificially a little bit. I'll just do that. We'll do a yes, another one. We'll watch the system load go up. And you might, for example, like if the VMs, for example, are consuming way too much CPU, you might want to shut one down and put it over on another machine so that your customers have more capacity and are not waiting for disk or anything else as much. So this is going to heat up my crappy little laptop. Any second you're going to see it's going to hit 1.5, I hope. We can run enough yes commands without overheating. Oh, there we go. It hits 1.7, and you can see that it shut down one of the VMs. All right? And now the load is going to drop down. Normally this would happen because the VM has been moved off. But once it goes below 1.5, we have this hysteresis property. And you're going to see that that's going to wait a full 10 seconds before it reschedules the VM on that system. So it dropped before 1.4, so we're in the green zone. 1.3, another few seconds, and you should see it automatically bring itself back online. And there you have it. Do you like that? Again, this is one simple, small example, but my goal is not to make your infrastructures and design how they should be built, but more give you a tool so that you can model how they're actually done. Make sense? All right, so let's kill that. I have a lot of stuff for developers. I'm going to maybe skip a little bit of it because I was running late. I can show you, I'm going to show you a little bit. How much time have I got? You got 5 minutes. All right. So really quickly, if you want to build one of these small resource components, they're actually relatively easy to do. And that's like how you can get involved. This tool is all written in Golang. It's a pretty safe, memory-safe language. And has some great properties that make it easy to build this sort of software. And by just imagining some kind of resource that you might want to build, it's quite easy. To implement a resource, you actually build like a struct in the language, which has a validate method so that it knows if it's being given the right properties. There's an init and a close method, which basically just do some startup and shutdown code for you. And then there's this check apply method, which is basically the code that puts your machine in the desired state. So if you've requested file contents foo and they're at bar, it'll just edit the file or start the service or any of those changes that you might want to make. And lastly, because we're event-based, we actually have this watch main loop that runs, the engine runs this per resource that will actually start up and detect when changes happen. And if a change does happen, it will notify the Mgmt engine, which will be able to run check apply. Okay, so very simple to implement. There's a bunch of example resources in the actual code, and so if you want to write one, that's great. Another thing, so in the language itself, there's function API. So that datetime example that I showed you, all these little primitives that are built into the language, any real-time property that you want to get information about and then model in the language is very easy to implement as well. The interface is quite small. You have to implement this info struct, which will actually just tell you, it will actually let you return some information to the engine about what your type signature is. So we're kind of a functional language, and we have very specific types that you have to promise to say, I'm taking a string and I'm returning an int, for example. So you give it that information. It has an init and a close method as well. When you call init, the engine will actually pass you some information about where you should talk to it, like, hello, call me on this number. And stream is actually the main loop for that function that will get called as well. The things that get passed in are very simple. You get a host name of the machine you're running on. You get some input and output channels about where you receive information, like incoming arguments, and some output about where you tell things that have happened. And there's a few other points that are not too important for this. I'm going to show you another quick demo. I actually I'm just going to kill these VMs because my laptop is really bad as it is. Just to show you how much you can actually be creative. So this is actually running on a remote machine, so please don't torrent for a second. But I just want to show you how powerful the resource API actually is. So these are the same machine, and I just have two terminals open on it. They're both running Mgmt on the host. And what I've done, I'll just show you in this screen session, Mgmt is actually running, and I'm just going to hide it in the background. And I've actually built a small little helper utility to make this demo have a little bit more flair, where it's going to actually put data into Mgmt. Kind of through that function API, it's going to say, hey, here's some data about something. And what it actually has done is it's actually started up a VM on that machine. Same as before, but here's the VM on the right here. And I'm running in that VM a little watch command, lscpu, and grepping the CPU string. And what you can actually see here, this is the number of virtual CPUs on this particular machine. And watch what happens when I push this plus or minus key over here. You can see that the number is actually going up. And if I press minus, it goes right back down. So what it's actually doing is you're just telling the Mgmt engine, hey, I want a VM with 2 virtual CPUs or 4 virtual CPUs or whatever. And it detects that the state on the machine is actually different from what you've requested. And it will actually work out which hot plug or hot unplug virtual API commands to actually hot plug and hot unplug that CPU from the machine. So you could actually implement, let's say you're a service provider hosting VMs or something, you could actually, when people have more load on their system, like you wanted to burst for the customers, you could automatically hot plug some CPUs, and when their machine is idle, you could shut those down. Just as one random creative idea. Do you like that? That's it? You're a very polite and quiet audience. So, I can dish it out, so happy to accept some heckling. So unfortunately, we don't have much more time, but if you did like this concept, I'm going to be showing some of these demos and a whole bunch of other stuff in 2 days in the main track. And so I'll just finish with 1 or 2 slides. How can you help? This is all about you. Use this, test it, patch it, share it, document it, tweet it, hack on this stuff.
Punk song.
Pardon me?
It's a Daft Punk song.
Oh, yeah. Heckler. Hang on, almost done. The only sad thing, so I work for this company called Red Hat, and they've been funding this work for about 1.5 years or so. But for political reasons, it has basically been defunded. So Mgmt has no home and no funding. So if you'd like to help, get involved in some way, or tell your friends about that, that would be definitely appreciated. Let's just recap. I think the audio computer is bad, but that's basically Arthur Benjamin saying he's just putting the cap back on his pen. He's recapping. Here are some links. You now know about the technical blog of James, right? Yeah, all right. All of the code is on GitHub. I'm Purple Idea, so purpleidea/mgmt. All the language bits are actually still in a feature branch. They're probably going to hit Git master itself in a day or 2, or very soon. There's a longer talk about the engine and another one about the language in some form, which you can actually find as well. And you can see a whole bunch of articles I've written on my blog and find me Purple Idea on these various places as well. If you want to see that main talk, on Wednesday at 3:50 in the green room, so green tech, I don't know, 3:50, come check it out. Please tell your friends if you think it's cool. I'm up against a lot of big name speakers, but I want to show that I can have better fire effects and entertainment than the other ones. So that's just some fun clip art. You have to help me with one little distributed denial of service. If you like this talk and you like what I'm doing, please go up to Chris after for 10 seconds and bother him and say, I really like James's talk.
Nothing to do with the rest of the conference.
Very well. And the other, you can also tell the LCA organizers. We have an IRC channel. Please come and hang out. Mgmt config on Freenode. We have a Twitter account. We have a mailing list. And that is all I have
Paul,
for now.
can you come down and plug in? Yes, that would be great. And I'll let James take some questions while we do that.
Cool. Thank you.
Wait, no, you need to be on the recording. No, he can't.
And if you would like a sticker, I have a few stickers. They're hilariously expensive. So if you'd like to have one and you'll use it,
Has anyone
grab it.
turned that into a build system?
Pardon me?
Has anyone turned that into a build system?
Not yet, but I'm happy to help you if you would like. So it's really a general purpose tool that lets you do what you want with it.
Anyone
So-
else?
Let me just hear this.
Apparently not. Oh, one
Yes.
more.
Sorry. Can you grab, careful, the projector
It's
is
the most
finicky.
difficult people ask the question.
I thought there was a break.
Is it cluster aware? Like, if it fails, can you run it? Can it be running on 2 or 3?
Yes, so unfortunately, it is cluster aware. There's a whole distributed systems component, which I think is probably the most impressive part. And these reactive functions actually can respond to things that happen on other machines and so on. Unfortunately, I just didn't have enough time to show you that today, but I will definitely be showing some of those things in the main track. So please come, and if I haven't answered your questions, ask again. Thank you.